Imagine for a moment you have this big, ambitious vision. Maybe it's a new community center, a cutting-edge research facility, or, even your dream home. Now, what if you could hand that entire vision over to one single, unified team?
Mm.
A team you could trust to handle every single step, from the very first sketch of an idea through every engineering detail, right down to the final nail being hammered into place.
Yeah, that sounds ideal.
No juggling separate architects and separate contractors, no playing the middleman, hoping everyone's, on the same page.
Yeah.
That, in its essence, is the core idea behind the design-build method. Today, we're taking a deep dive into your collected materials to unpack its fascinating story, its surprising historical roots, and what it truly means for how we conceive and construct our built environment today. Okay, let's unpack this.
Indeed. What our materials really dig into is a project delivery method that essentially puts both the big picture design and the hands-on building under one roof, a single team taking responsibility for the whole thing.
One point of contact.
Exactly. It's an approach that's really gaining traction today, and what's particularly fascinating here, I think, is how it isn't really a new concept at all. But rather, in many ways, it's a thoughtful, almost deliberate return to much older ways of working. It's a rediscovery almost of an integrated philosophy.
That's a crucial insight right there. So our mission today is to trace this intriguing historical journey, compare design-build to the more traditional methods we've become accustomed to. We want to eliminate its primary advantages, and we're talking about things like streamlined communication, significantly faster project delivery, and much clearer cost certainty.
Yeah, those are the big ones.
But also, we need to candidly address its potential downsides and maybe the situations where it might not be the best fit.
Sure, no silver bullet.
Exactly. This isn't just about different ways to build. It's a comprehensive look at how we're fundamentally reshaping roles, relationships, and even mindsets within project teams to achieve better outcomes. When you first hear the term design build, it almost sounds like a modern innovation, doesn't it?
It does, yeah.
Something born out of our quest for efficiency and integration in the 21st century. But I was fascinated to learn from our materials that this isn't a modern invention at all. It actually harks back to ancient times. It echoes through centuries of building history. What did you discover about that historical continuity?
What's truly fascinating here, as you've highlighted, is precisely that historical continuity. Before the clear separation of roles we often see today in the construction industry, where you have one person designing and another executing, there was indeed a pervasive master builder model.
A master builder.
Yeah, this wasn't just a quaint idea. It was the standard way of working for millennia, reflecting a really holistic approach to creation.
So we're talking about a time when the person envisioning the structure was also deeply involved in and responsible for how it would actually come together physically. It sounds like a singular, powerful vision at play.
Precisely. Let's look at a few vivid examples from our materials that illustrate this. Think of medieval Europe and the awe-inspiring structures like the great cathedrals that dot the landscape.
Okay.
The individuals responsible for their creation were frequently known as master masons.
Master masons.
Right. These weren't just skilled laborers. They were highly educated and experienced individuals, deeply versed in both the artistic design, the aesthetics, the symbolism, the spatial flow, and the practicalities of construction. Things like structural integrity, material properties, the logistics of building at scale. Our sources specifically highlight the integral role of these master masons and even mention the secrecy in guilds, which further indicates how this integrated knowledge and control was maintained, protected, and passed down through generations.
Wow.
They held a complete architectural vision and possessed the intimate technical knowledge and authority to execute it, ensuring a consistent design intent from top to bottom. Their decisions weren't just about form, but about the very physics of how those massive stones would interlock and rise towards the heavens.
So the very people who were literally shaping the stones understood the grand design and its every minute detail. That profound connection between concept and craftsmanship must have been incredibly powerful for projects of that scale and complexity, where an error could be, catastrophic.
Absolutely. And even earlier, if we look at classical antiquity, the construction of magnificent structures like the stone temples of mainland Greece with their intricate Doric order, that provides further compelling evidence of this integrated approach. Our material points out that these required an astonishing homogeneity and visual certainty in their execution,
Right.
something that strongly suggests a closely integrated design and construction process. The evolution from conventional timber forms to masonry in these structures wasn't just a material swap. It seized upon new technologies and sophisticated engineering while simultaneously restating core themes of religious architecture. This implies a singular guiding intelligence, someone who understood both the aesthetic aspirations for spiritual spaces and the material realities of building with such precision. There wasn't a separate team just drawing a pretty facade. There was an intrinsic link between the structural system and the finished appearance, executed by a unified vision.
That continuity, where the aesthetic and structural were intertwined from the ground up, must have been a powerful force. It contributes to the timeless quality of these ancient wonders.
Definitely.
But what about closer to home, say in early North America? Was this master builder model present there too?
Moving to North America, yeah, the early timber-framed barns and houses offer another compelling and perhaps more relatable example.
Okay.
These were often built by carpenters who had emigrated from forested European countries, bringing with them a fully developed integrated knowledge of how to construct robust, efficiently braced frames. Our source material details how these structures relied on hand-hewn wooden timbers joined by intricate interlocking wood-to-wood connections.
Ah, like mortise and tenon.
Exactly. And significantly, nails were scarce and expensive at the time.
Right.
This meant the builders themselves were deeply involved in both the structural design and its execution, embodying that single point of responsibility.
Yeah.
They understood the properties of the wood, how to cut and join it for maximum strength, and how the entire frame would withstand the forces of nature.
Mm-hmm.
The fact that many of these structures are centuries old and still in service is a powerful testament to the structural ingenuity and prowess of their builders. They were literally both the designers and the constructors.
It's incredible to think that some of those buildings are still standing centuries later as a direct result of that integrated approach.
It really is.
It speaks volumes about the quality and foresight embedded in that singular vision. You can almost feel the immense pride and ownership that must have come with knowing you were both the visionary and the craftsman of something so enduring.
Indeed. And even a figure like Andrea Palladio, working in the more developed context of the Italian Renaissance, cultivated a specific deep expertise that echoed this integrated ideal. He was considered a specialist assistant in architectural theory and engineering, intensely focused on his discipline rather than being a generalist. He didn't just passively draw, he actively imposed his own rationalism on ancient sites. And his reconstructions of ancient villas often showed a characteristic Renaissance order, of a kind that did not interest the ancient Romans.
Interesting.
This, as noted in our sources, suggests an integrated, decisive vision, from conception through to what he believed was the correct execution. His referencing of Vitruvius's detailed descriptions of architectural elements also points to the holistic understanding required of these master builders.
Mm-hmm.
They weren't just sketching pretty pictures. They understood the very essence of how things stood up, how materials behaved, and how every part fit together to form a functional and beautiful whole.
So for a very long time, this integrated model, this master builder concept, was not just common, but seemingly the natural, most effective way to build.
It seems that way, yes.
But then something shifted dramatically. We moved away from this master builder model, and a different philosophy took hold. Here's where it gets really interesting. What happened to change this age-old tradition, to break apart that unified vision?
The Industrial Revolution really brought about a profound specialization that fundamentally altered the building process, leading us away from that integrated model. It was less a conscious top-down decision and more an evolutionary, almost inevitable shift driven by new technologies and changing economic forces.
How did that process unfold? Was it a sudden break or more of a gradual drift toward specialization?
It was a gradual but ultimately pervasive transformation. Consider the introduction of water-powered sawmills, for instance.
Okay.
They could mill lumber far faster and more consistently than hand-hewing. And then, crucially, the widespread availability of inexpensive wire nails in the mid-19th century.
Ah, the nail changed everything.
It really did. It fundamentally altered how buildings were constructed. Our source material highlights how these innovations led to the dominance of the wood-light frame construction.
Right, balloon framing, platform framing.
Exactly. Suddenly, materials became standardized and more easily mass-produced, and the act of construction could be broken down into more distinct, repeatable tasks. This allowed for different trades to specialize: carpenters, masons, roofers, plumbers, each focusing on a narrow slice of the process. The need for a single master builder who understood every aspect of the project began to diminish as the components became more modular and the tasks more fragmented.
So instead of a single craftsperson overseeing everything, you had different people, different companies, each responsible for a specific part of the building process. It sounds like efficiency, but also maybe a potential loss of that overarching unity.
Exactly. And this specialization wasn't just on the construction side. The 19th century also saw architecture itself become, as one source puts it, addicted to period pieces and elaborate historical styles.
Stylistic revivals.
Precisely. Architects were often applying new building techniques merely to produce old effects, focusing more on the look of a building, as noted in another source, rather than its integrated performance or the long-term effects of time. This era emphasized aesthetics and stylistic revivals, often at the expense of that unified approach to design and construction that the master builder embodied,
So the architect became more of an artist, a stylist.
and less involved with the nuts and bolts of how the building would actually perform or how practically it could be built. This shift in focus created a growing chasm between the creative vision and the practical execution.
And this separation, this growing chasm between design and construction, paved the way for what became the more common method we see today: design, bid, build. It's a process that, while familiar and deeply entrenched, brought with it its own unique set of complexities, which ultimately prompted a reevaluation and, well, a modern return to that ancient wisdom of integration. So, if the master builder was the integrated chef of the ancient world, creating both the recipe and the meal with a single vision, then design bid build became the modern restaurant.
Okay, I like that analogy.
You've got separate designers creating the menu and separate chefs preparing the meal. And you, the owner, are essentially running the entire restaurant, coordinating everything, trying to make sure the menu designer and the chef are actually talking to each other.
That's a pretty good picture of it. In the traditional design-bid-build process, the owner truly acts as that central coordinator, playing the role of the general manager, essentially. They manage separate contracts with the designer, usually an architect, and then separately with the builder, or general contractor. It's a distinctly sequential process, quite a departure from the integrated approach we just explored.
Sequential is the key word there.
Yes, and each phase is often seen as discrete.
Can you walk us through those distinct phases and clarify what happens at each stage?
Of course, it typically begins with the design phase. Here, you, the owner, contract an architect or a design firm to create all the plans, drawings, and specifications. These documents are absolutely crucial in this model, serving as the definitive guide for the entire project. Our sources explain that they serve to convey the requirements of the project to potential bidders and establish a legally precise picture of the technical aspects of the work.
Legally precise, that sounds important.
Very. These aren't just conceptual sketches. They are legally binding documents that meticulously define quality levels, standards of workmanship, and material standards, often citing specific brand names or requiring an equal item. They lay out exactly what is to be built, down to the last bolt and finish. The owner's primary relationship at this stage is almost exclusively with the designer.
So the design has to be fully realized and incredibly detailed before any builder is even brought into the picture, before anyone even starts thinking about how to physically construct it.
Precisely. Only once that comprehensive design is essentially completement, meaning all the drawings, specifications, and details are finalized and approved by the owner, does the project move into the bidding phase.
Okay, the bidding.
Here the project goes out to bid, and multiple contractors review these extensive, detailed plans. They then submit proposals or bids based on these documents. As noted in our materials, the scope of work for the construction is meticulously defined by these finalized construction plans and written specifications. It's an opportunity for multiple contractors to compete for the construction phase of the project, often based primarily on price, with the lowest compliant bid usually winning.
Lowest bidder usually gets the job.
Often, yes.
Yeah.
And then after evaluating those bids, you, the owner, make your selection and hire a builder. Exactly. The final stage is the construction phase, where the owner then awards a separate contract to a builder or general contractor. This creates a clear contractual division. The owner holds one agreement with the designer and a separate agreement with the builder. The designer typically remains involved during construction, often in an oversight role, to ensure the builder is adhering to their plans and specifications, acting as the owner's representative regarding design intent.
So you, the owner, are effectively managing two distinct relationships and two distinct contracts.
That's the structure.
This structure seems to create a natural check and balance, doesn't it? with the architect as the original designer and the owner's advocate overseeing the contractor to ensure the design is followed to the letter. On paper, it sounds like a robust way to maintain quality control and protect the owner's interests. But what does this all mean for the project's journey from concept to completion in the real world? Does it always work out so cleanly?
That's a crucial observation, and it raises an important question about the implications of this inherent separation, which can be quite significant in practice. While the design bid-build model is indeed intended to provide those checks and balances you mentioned, where the independent architect oversees the contractor, it can also paradoxically lead to unintended consequences and friction.
Such as, what's the real cost beyond just potential disagreements? Where does it get messy?
Well, one major implication is the potential for conflict and an adversarial dynamic. Because the roles are so distinct and the contracts separate, a natural tension can sometimes develop between the designer and the builder.
Uh-huh.
Designers, having completed their work in isolation from the construction realities, might create plans that are brilliant on paper, but incredibly difficult, inefficient, or expensive to construct. Conversely, builders, having had no input on the design, might feel little ownership over the design intent itself, focusing purely on executing the plans as provided, even if they see more efficient or practical ways to achieve the same outcome.
Right, just build what's drawn.
Exactly. The real cost of this adversarial dynamic isn't just legal fees or change orders. It's the squandered opportunity for shared innovation, where a designer's vision and a builder's practical ingenuity never truly converge to create a superior product. When issues inevitably arise during construction, and they always do,
Always.
this separation can lead to finger-pointing, disputes over who is responsible, who bears the additional cost, and how the schedule will be impacted. Everyone points to the contract, and true collaboration can suffer dramatically.
So what looks like a clear division of labor can actually become a division of responsibility that creates friction and ultimately compromises the project's potential.
Precisely. Another significant challenge is the poor information flow and communication silos. In this segmented approach, information might not flow as freely or efficiently between the design and construction teams, simply because they often operate as distinct entities, sometimes even competitors during the bidding phase.
Yeah, they just competed against each other.
Right. Designers might not have easy access to real-time constructability insights from the field, leading to designs that aren't optimized for current materials or building techniques. Builders, on the other hand, might have questions or interpretations of the plans that, in a more integrated environment, could have been resolved much earlier with a quick conversation. Instead, these issues might surface only during construction, leading to costly requests for information, RFIs, delays, and rework. It can become a game of pass the buck rather than solve the problem together, where vital insights are held within separate silos instead of being shared for the collective benefit of the project. This lack of early, fluid communication often translates directly into higher costs and extended schedules.
So while design bid build is the traditional and still widely used method, its inherent separation of design and construction, while offering a form of checks and balances, can sometimes create significant friction and inefficiencies, particularly when it comes to communication, problem solving, and realizing the full potential of a project. It's a system built on distinct silos, and that can lead to unforeseen challenges and often a less optimized outcome.
That's a good summary of the potential pitfalls, yes.
Given those potential sticking points and inefficiencies in design bid build, it becomes clearer why our sources highlight some powerful advantages in the integrated design build model. Instead of those two separate contracts where you, the owner, are juggling an architect and a contractor, you essentially have one firm responsible for both design and construction. It's like bringing the chef and the menu designer into the same kitchen from day one, having them collaborate on every aspect of the meal, sharing one budget, one vision, and one goal.
Exactly. That's the core idea. This integrated model is intentionally designed to foster inclusive and collaborative environments where knowledge and expertise are more freely exchanged, as articulated in one of our key sources. This approach fundamentally aligns interests from the outset, moving away from separate contractual obligations to a unified goal. The entire team is incentivized to work together for the project's success.
So let's dive into those advantages, starting with how this unified approach impacts communication and the potential for errors. That seems like a big one.
Absolutely. The first major advantage, and perhaps the most immediate, is streamlined communication and dramatically reduced errors. When designers and constructors are part of the same team or a single consortium from the very beginning, they are inherently motivated to work with other members to minimize delays and disputes, according to another source.
Makes sense. Shared fate.
Precisely. This means that crucial construction expertise, the practical knowledge of what works, what doesn't, what's efficient, and what's difficult in the field, can directly inform the design process from day one. You avoid situations where a design is brilliant on paper, but incredibly challenging, expensive, or even impossible to build, because the people who know how to build it are at the table during the design phase.
And modern technology really amplifies this, doesn't it? I'm thinking specifically about building information modeling, or BIM. That seems like a perfect fit here.
You're absolutely right. BIM is a game changer here. This is where modern technology truly shines in a design-build context. BIM enables what we call virtual construction. It allows construction managers and supervisors to essentially practice putting the pieces together before they actually commit to the labor and materials, as the BIM handbook explains.
A digital dress rehearsal.
Exactly. Think of it like that. A key tool here is clash detection. This is where models from all disciplines, architectural, structural, mechanical, electrical, plumbing, are brought together and compared systematically. This allows teams to identify hard and clearance clashes, like a structural beam going right through an HVAC duct, or a pipe infringing on a required maintenance zone.
Oh yeah, classic problems.
Right. And other potential errors virtually, long before they ever reach the physical field. Our standards of practice materials also heavily emphasize this capability, recognizing its immense value.
So they're catching these potentially costly problems on a computer screen instead of on the job site, which must save an enormous amount of time, money, and headaches.
Huge savings, yeah.
But beyond just catching errors, does this virtual environment also unlock entirely new ways for designers and builders to innovate together? Maybe trying out ideas that would be too risky or expensive in the real world.
That's a brilliant question, and absolutely, it goes beyond mere error detection. The true insight here is that by front-loading this collaborative problem-solving, design build doesn't just catch mistakes, it fundamentally shifts the project's risk profile. Design flaws, which in traditional models could become costly finger-pointing exercises and legal disputes, are instead absorbed and resolved internally within the integrated team.
Ah, okay.
This fosters a shared ownership of success rather than individual blame. Furthermore, this virtual environment becomes a sandbox for innovation. Teams can experiment with different structural systems, material choices, or energy strategies, immediately visualizing the implications and optimizing for performance, cost, and constructability without the prohibitive expense of real-world mock-ups or change orders. This proactive approach significantly reduces design errors and omissions before construction begins, speeds up the overall construction process, minimizes the likelihood of costly legal disputes, and ultimately provides a smoother, more efficient, and often more innovative process for the entire project team.
That's incredibly powerful. So fewer errors and more innovation. But beyond just catching mistakes, does this integrated approach also mean projects get done faster? Speed is often critical.
Yes, that leads directly to the second major advantage: faster project delivery. The immediate availability of contractor knowledge of constructability can inform the design process and help to reduce model revisions and thus cost and time, as highlighted in the BIM handbook.
Right.
This means designs are inherently more buildable from the very start because the people who actually construct it are providing input during the design phase. For instance, a designer might propose a complex facade detail that looks stunning but would be incredibly time-consuming and expensive to fabricate and install. With a design build team, the contractor's input ensures that such a detail is either modified to be more efficient without losing its aesthetic intent, or an alternative, equally effective, and more constructible solution is found early on. Less rework.
And how does scheduling play into this accelerated delivery? I heard about 4D scheduling, for example. What is that?
You're right to bring up 4D. Our materials mention 4D schedules, which dynamically link project CPM, that's the critical path method, schedule activities to 3D objects in the BIM model. The standards of practice describe this as providing a graphically rich and animated representation of the planned construction sequence set against time.
So you can watch it being built digitally.
Very much it.
Yeah.
You can virtually watch the building go up step by step before any physical work begins. This is an incredibly powerful tool for phasing, coordinating, and communicating work to everyone involved, from subcontractors to owners. Crucially, it also supports simulated what-if scenarios, allowing teams to optimize sequences, identify potential bottlenecks, and foresee potential delays before they impact the real-world schedule.
What if scenarios? Like,
Well, they could test if bringing in a certain trade earlier would shave weeks off the project, or if a delay in raw material delivery would create a cascading effect throughout the entire timeline. They can play it out virtually.
so they can essentially run simulations of the entire construction timeline and adjust as needed, reducing real-world delays. It sounds like a hyper-efficient planning tool.
Precisely. By resolving issues virtually and planning in such an integrated and dynamic way, the actual construction can proceed with significantly fewer interruptions and surprises. This overlapping of design and construction phases, often called fast tracking, is a hallmark of design build, leading to significantly faster overall project completion compared to the sequential nature of design bid build.
Right, that overlapping.
Time is often money in construction, and design build aims to save both by compressing the schedule.
And speaking of money, I understand design build also offers greater cost certainty, which is a huge factor for any owner embarking on a large project. Budget blowouts are the nightmare scenario.
It absolutely is, and this is the third significant advantage: greater cost certainty. With an integrated approach, especially with something called IPD, Integrated Project Delivery, which is closely related where general and trade contractors participate during the design process, as one source notes, accurate cost estimates can be developed earlier in the design.
Earlier is better for budgets.
Definitely. This early accuracy is absolutely crucial for securing financing for large projects. In traditional models, owners often receive cost estimates only after the design is largely complete, leading to potential budget shocks and redesigns. Design build brings cost expertise to the forefront much earlier.
How does BIM specifically contribute to this early cost certainty? Does it help with the numbers?
Yes, BIM also enables what's called 5D cost management capabilities. With this, every element in the model, from a specific type of window to a length of piping, can be attributed to resources and their respective costs.
Ah, the fifth dimension is cost.
Right. The standards of practice explain that this facilitates parametric and dynamic quantity takeoff for bills of materials, leading to far more accurate and real-time estimates. Instead of manual counting and calculations, the system can instantly generate material lists and associated costs as the design evolves. This, importantly, frees up project teams to spend more time on strategic cost analysis, exploring different material options, evaluating lifecycle costs, performing value engineering rather than just basic quantity surveying.
So more brain power on optimizing costs, less on just counting things.
Exactly. And what this means for the owner's budget very early in the project is quite significant. Does it provide a fixed price?
Yeah, can you get a fixed price early?
Well, for owner clients, a consortium-based approach like design build can often offer a stipulated sum price, essentially a guaranteed maximum price, or GMP, for the project after only 30 to 40% of the design is completed.
Only 30 to 40% done, that's early.
It is. This is a crucial distinction, as our sources highlight. It provides a definitive cost figure much earlier than in traditional methods, which is incredibly attractive to owners and lenders alike because it significantly reduces financial risk and the need for large, nebulous contingency funds. Model-based budgeting can then be actively used for options analysis and value engineering, allowing the team to modify the design to match the budget if necessary, ensuring financial viability without compromising core objectives.
So you know your financial exposure much earlier, and that makes planning and financing much more predictable. That's a huge de-risker for any large investment.
It is. And finally, the fourth major advantage, which kind of underpins many of the others, is the construction expertise directly informing design.
This sounds like the core benefit almost.
It's arguably the most direct and intuitive benefit of design build. Instead of the designer creating a plan in isolation that the builder then has to figure out how to execute, the builder's practical knowledge, their understanding of logistics, materials, processes, is woven into the design from the very beginning. This helps proactively in avoiding constructability issues, perhaps suggesting a different method for erecting a complex steel frame or an alternative foundation system that will save time and money. It helps in selecting more efficient materials and optimizing building systems for real-world application, not just theoretical perfection.
So the people who know how to build it are actively helping design it. That sounds like common sense, but it's such a fundamental departure from the traditional model, which often feels like two separate worlds just throwing things over the wall to each other.
Absolutely. And during design reviews, BIM allows for what are called virtual hard hat reviews. This is essentially a virtual walkthrough of the model to examine job site logistics, construction sequencing, and the facilities being constructed.
A virtual walkthrough.
Yeah. Imagine walking through the future building, seeing where equipment will be placed, how materials will be hoisted, or where temporary structures might impede access. This level of engagement, outlined in the standards of practice, ensures that designs are not just aesthetically pleasing or structurally sound on paper, but also practical, safe, and efficient to build in the real world. It bridges that historical gap between the drawing board and the construction site, ensuring that the finished product is optimized from every angle. Hashtag tag 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 4. Potential downsides and challenges.
Okay, it sounds like a truly transformative approach, especially with modern tools like BIM that allow for such incredible levels of visualization and collaboration. It seems to fundamentally de-risk and speed up projects in many cases.
It often does, yes.
But, no method is perfect for every single situation, and every coin has two sides. So what does this all mean for potential drawbacks or complexities? What are the things you need to carefully consider if you're thinking about using design build?
That's right. While the benefits of design build are indeed compelling and often profound, this integrated structure does raise an important question that warrants careful examination. What happens to the traditional checks and balances that existed between a separate architect and a separate builder in the design bid build model?
That's a critical point. In design bid build, you have the architect, who typically works directly for the owner and acts as an independent watchdog, right? Overseeing the contractor.
Hmm.
That provides an independent layer of quality control and advocacy for the owner's interests. How does that work in design build?
Exactly. The design bid build model has that inherent system where the independent architect oversees the contractor's adherence to the design and specifications. In design build, with a single entity responsible for both, that distinct separation of oversight is inherently altered. Now, this isn't necessarily a flaw, but it changes the dynamic. Our materials suggest that an owner using an at-risk delivery method—
Meaning the design build firm takes the risk on cost overruns.
Yes, exactly. Meaning the design build entity guarantees a maximum price, taking on significant financial responsibility and holding the financial risk for cost overruns. That owner might even consider hiring another consultant to provide agency PM project management to represent their interest, as noted in the standards of practice.
Ah, so hiring your own independent rep.
Potentially, yes.
Yeah.
This indicates a perceived need for some form of independent representation to ensure the owner's interests and original vision are still being fully met, especially when the combined entity is taking on certain financial risks. Someone looking out just for the owner.
So while you gain efficiency and potentially lower costs through integration, you might lose some of that independent scrutiny that an architect traditionally provided. And that at-risk component sounds like it could create a subtle tension, maybe.
It absolutely can. This at-risk arrangement, while fostering collaboration by having the design-build team share in the financial consequences, also means they're intrinsically incentivized to control costs. That's their risk. This can, at times, create a subtle tension, if not carefully managed. It might lead the team to make design or material choices that prioritize their budget commitment over, say, a particular aesthetic preference or long-term performance benefit the owner initially envisioned.
Unless those are locked down tight in the contract.
Precisely. Unless those parameters are extremely well-defined up front. It's why our materials suggest an owner might need an independent advocate for their original vision and quality expectations, essentially ensuring someone is looking out purely for the owner's best interests throughout the process.
That clarifies a significant nuance. This leads into another potential challenge you mentioned, risk and scope definition. Getting that scope right sounds crucial.
Indeed. Another challenge arises with risk and scope definition. The at-risk arrangement, while beneficial for shared responsibility, can create unmanageable risk for the design-build entity if the program management scope, the overarching objectives, and qualitative requirements of the project is difficult to define with sufficient accuracy at the outset.
Qualitative requirements, like what?
Well, this is particularly true because program management activities are more often qualitative than quantitative, focusing on outcomes like stakeholder satisfaction, community impact, or long-term operational efficiency, rather than purely measurable construction tasks like pouring concrete. These qualitative aspects are also more often controlled by third parties. Think local authorities, utility companies, or community groups, which adds another layer of unpredictability.
External factors.
Right. If the initial scope isn't crystal clear, especially those qualitative goals, this can lead to misunderstandings, disputes, and multiple changes that are much harder to resolve within an integrated team. Precisely because everyone is already financially tied to the project, unlike the arm's length relationships in design bid build. Defining those initial parameters precisely, especially the qualitative ones, is absolutely key to preventing later friction.
It sounds like the very integration that offers benefits can also make it harder to untangle problems if the groundwork isn't laid perfectly, especially when dealing with those less tangible aspects of a project.
That's a very astute observation. And on a broader organizational level, there's the issue of complexity management. Generally, increased complexity in any business can create problems of communications, leading to more layers of management, special coordinators, more forms and procedures, and more delays in making decisions as detailed in one management source.
So design build isn't automatically simpler.
Well, while design build aims to simplify the external interface for the owner, presenting a single point of contact, it often shifts a vast amount of internal complexity onto the integrated firm itself. This isn't just about combining two departments, it's about blending distinct professional cultures, the creative, often iterative world of design, and the highly structured, execution-focused world of construction.
Different mindsets, yeah.
Very different. This integration demands incredibly robust internal communication channels, clear hierarchies, and a shared ethos that can overcome inherent differences in approach and priorities. Without this robust internal governance and a truly collaborative culture, design-build firms can inadvertently create their own bureaucratic layers, special coordinators, and new procedures, potentially leading to delays in decision-making within the firm, even as the overall project timeline is theoretically compressed.
So the complexity doesn't just disappear, it just shifts internally to the design build team, requiring a highly sophisticated internal organization to manage it effectively.
Exactly. And even with all the advanced tools we've discussed, BIM implementation itself can present challenges. Even though BIM is a powerful enabler for design build, the technology is still evolving, and its effective adoption isn't always straightforward.
It's not plug and play.
Not at all. Early BIM programs, for instance, might not provide the broad spectrum of functionality needed for general concept design, often requiring designers to work with rigid modeling conventions, or even necessitating restructuring of the model as the design progresses, as stated in the BIM handbook. This means there's a significant learning curve and a need for highly skilled personnel who are adept at both design and the intricacies of the software.
So it's not simply a matter of buying the software and pressing a button. There's a real art and science to implementing BIM effectively, and you need the right people.
Far from it. There can also be difficulties in interfacing easily and efficiently with existing BIM authoring tools from different vendors, creating data exchange issues, interoperability challenges.
Ugh, data silos again, but digital ones.
Kind of, yeah. Furthermore, managing distributed data sets for analysis, where different parts of the model or different analyses are being run by various team members, can lead to issues with tracking which analysis run corresponds to which design version. This can create confusion and undermine the very integration BIM is supposed to facilitate. So, adopting BIM effectively within a design-build framework still requires careful planning, significant investment in training, specialized expertise, and a commitment to continuous improvement in workflow and technology. The tool is powerful, but its effective use is a discipline in itself and a challenge many firms are still navigating.
So while design build presents some incredibly compelling advantages, efficiency, cost certainty, collaboration, it's not without its complexities. Owners need to be mindful of how independent oversight is maintained, how clearly the scope is defined, particularly those qualitative aspects, and the internal complexities that the integrated team must manage. Not to mention the nuances and challenges of effectively adopting sophisticated technologies like BIM. Lots to consider.
Definitely. It requires careful planning and the right team structure.
Given these nuances, and the fact that no single project delivery method is a silver bullet, design build clearly isn't a one-size-fits-all solution for every single project out there.
Right.
So, for you, the listener who might be considering this approach, when is this integrated model most successful? What kind of projects truly shine with design build? Where does it make the most sense?
That's the key question. If we connect this to the bigger picture, success in project delivery, particularly with design build, comes from tailoring based on context, as the PMBOK guide emphasizes. It's about a deliberate, thoughtful selection process, recognizing that different projects have different needs, different complexities.
What does that contextual adaptation really entail? How do you assess a project to decide if design build is the right fit? What are you looking for?
It's about making a deliberate adaptation of approach, governance, and processes to make them more suitably for the given environment and the work at hand. Key factors to consider include the specific business environment, the size of the team, the degree of uncertainty surrounding the project, how many unknowns are there at the outset, and its overall complexity. The goal is always to maximize value and manage constraints by using just enough processes and methods, not too many, not too few, to achieve the desired outcome efficiently. You're trying to find the sweet spot for that particular project, balancing the client's needs with the project's inherent characteristics.
So it's about understanding the unique DNA of your project and matching the delivery method to it, rather than forcing a square peg into a round hole.
Exactly. And design build truly shines in projects where early collaboration and the seamless integration of design and construction knowledge are absolutely critical. This is where its core strengths align perfectly with project needs, minimizing the friction points we discussed earlier.
Can you give us some specific examples of those kinds of projects where design build really excels, where it's almost a no-brainer?
Certainly. One category is complex or technically demanding projects. Think of large-scale infrastructure like bridges, tunnels, complex public transportation hubs, or highly sustainable, cutting-edge buildings.
Okay, the really tricky stuff.
Yeah. Our materials mention green skyscrapers, such as the Pertamina Energy Tower, the Shanghai Tower, and the Pearl River Tower. These are structures that integrate advanced, often experimental energy strategies like geothermal, solar, and wind energy. They employ sophisticated exterior sunshades for blocking direct sunlight and emitting daylighting, and utilize innovative radiant cooling systems.
Very complex systems interacting.
Extremely. To achieve ambitious certifications like LEED Gold Platinum and Net Zero energy goals, you need a deeply integrated approach from day one. There's just no room for disconnect between concept and execution. Imagine trying to integrate a complex geothermal system where the piping needs to run through structural elements or interact with the building's facade. A traditional method would likely involve endless clashes and redesigns.
Nightmare.
Design build brings the engineers, architects, and contractors together to solve these challenges holistically from the outset, optimizing every system and material choice for both performance and constructability.
Those are incredibly intricate projects where every decision has cascading effects across multiple systems. That early, unified expertise seems absolutely invaluable for both innovation and just getting it built right.
Absolutely. Another category is time-sensitive projects. When speed is paramount, perhaps due to market demands, critical operational deadlines for a new factory, or an urgent need for an emergency facility, the design-build method's ability to overlap design and construction phases.
That fast tracking again.
Exactly. Made incredibly efficient by tools like 4D scheduling, it can significantly reduce the overall project duration. The sequential nature of design bid build, where each phase must largely complete before the next begins, just can't compete with the parallel processing that design build allows. Imagine a hospital needing to expand its critical care unit quickly in response to a public health crisis. Design build can potentially compress a multi-year timeline into a much shorter window, getting the facility operational when it's most needed.
So if you need it yesterday or at least much sooner, design build might very well be your best bet for accelerating the timeline.
Often, yes. And a third key area is cost-driven projects with early certainty needs. For owners who require a definitive cost figure very early in the process, design build is highly attractive. The stipulated sum price, or GMP approach, offered by a consortium-based design build team after preliminary design, provides that crucial financial certainty. This is especially important for securing project financing, as lenders appreciate having a locked-in cost figure early on, which significantly de-risks their investment, as noted in our sources. Knowing your maximum financial exposure up front allows for far more stable budgeting and financial planning, avoiding those nasty surprises that can derail projects further down the line. It offers a predictability that many owners highly value.
That makes a lot of sense. Knowing your financial exposure up front is a huge advantage for any large investment, allowing for more confident decision-making. Peace of mind, maybe?
It can be. And beyond the project type itself, success also hinges on clear roles and responsibilities within the integrated team. Even within a single design-build entity, clarity is vital. The PMBO guide stresses that governance functions, the mechanisms and people responsible for approving recommendations, monitoring progress, and maintaining clear linkages to strategic objectives are absolutely essential.
So who does what?
Exactly. Everyone needs to know their part, their authority, and their accountability to ensure the collaborative environment remains effective and avoids the pitfalls of internal confusion or a diffusion of responsibility that can sometimes creep into highly integrated teams. Strong leadership and clear communication protocols are non-negotiable.
So it's about finding the right fit for your project, recognizing when a project's complexity, timeline, or financial requirements benefit most from a unified vision and execution, and then ensuring that the integrated team itself has clear internal structures and strong leadership to manage that inherent complexity effectively. It truly is about optimizing for success based on context.
That sums it up nicely. Tailoring is key.
Yeah.
Hashtag tag tag outro.
This deep dive has shown us that the design build method is really a powerful blend of ancient wisdom, harkening back to those master builders of old, seamlessly integrated with the incredible capabilities of modern technology. It's reshaping how we conceive, design, and create our built environment. It's a fascinating journey from the solitary craftsman to the virtual construction site.
It really is a powerful case study in the benefits of aligning interests and fostering true collaboration. Moving beyond traditional silos to create a more efficient, responsive, and often more innovative project delivery system. The integration of roles, powered by sophisticated tools like BIM, means we're fundamentally rethinking how design and construction interact. And the outcomes can be truly transformative for projects of all scales, from a small community library to a towering green skyscraper.
And it makes you wonder about the broader implications beyond just the building site itself, doesn't it?
How so?
Well, as our materials remind us, cultivating an informed, engaged, and passionate population in a world of increasingly complex and accelerating technologies is one of the great challenges of the 21st century. Could this integrated approach, by bringing together diverse expertise earlier and more directly, not just streamline construction, but also foster a more informed and engaged citizenry in shaping their own built environment?
Interesting thought. Community involvement.
Imagine a future where project teams actively bring community stakeholders into the virtual design process, using BIM to visualize and co-create, much like the master builders once worked directly with their patrons, perhaps. What new possibilities does this open for creating vital, fair-minded, humane settlement patterns that truly serve people for the century ahead? Could it potentially even help us return to a more local and user-centric model as envisioned in some discussions about future craft and the city of tomorrow?
That's a fascinating projection.
What could we achieve if we truly empowered everyone to be part of the design and building of their own world? Food for thought.